Welcome back to the third part of our tutorials on the virtual observatory of GAIA-CLIM. In this short tutorial, I'll be talking about the metadata that's in the database. Speaking of databases, there's an underlying database that holds both the metadata and the observational data that I will show in the next video. The metadata is discovery data, which describes which network has what observations, what products, in at what locations, over what period of time, who is the PI to contact, where do I find the original data, how mature is the data set, and a couple of other things. All this data is stored in a Mongo database, which is a non-relational database, meaning it's object-oriented. I don't have to decide at ingestion the layout of the database, and I can change records, I can add fields or remove fields, and it handles all that very gracefully, which is of course good if you have so many different types of measurements that differ in their nature. And also if we may add different products, different instruments in the future that may require different format. This database is shared for the metadata and for the actual observational data. And there are no duplicates in there, so whenever we ingest, the metadata is all ingested already. As we progressively ingest more observational data, we check if there's already a metadata entry for it and then update that entry so there are no duplicates in the database. Now, looking on the website, at the top menu we have metadata. In here there's an area where we can select what networks we might want to look at. There are a couple of other fields that are not active yet. So let's start with this one. This is only the development server. The actual server held by Working Package 1, which has collected all this data, so their database has tens of thousands of entries. But here on the development server where we work on the GUI and these things, we only have examples from 2 networks that representatively can be used to show the functionality. We have here, for example, EarlyNet, which is a reference network of LiDARs that look like aerosols. We can send a data request, and then we will see on a map where there are observation sites for EarlyNet. And if we hover our mouse over it or make a short click somewhere here, for example in Turkey, then we can see that this is Limassol, and it's part of EarlyNet, and it's at latitude 34.67 and longitude 33.04. We could also look at other sites if we wanted to. We could change the network and say, look, now we're going to look at Guan sites. Here the drop-down box normally would also show, may show more than one entry. And it tells us the metadata is reported according to different standards. There's the WIGOS standard from WMO, there's an ISO standard, and there's also MetaCF standard that are commonly used. All 3 standards are supported for ingestion into the database. Then for displaying, we have a set of harmonized naming conventions, so the user can plot data independent of where the original data comes from. But if you were to export data from here, then you could get the original data format, the original ISO format in this case, or if it were WIGOS, you would get the original WIGOS format. Okay. And now we can see there's a second layer now here. So the first layer in green was EarlyNet, and the second layer now is Gruan sites that send up radio songs. We can disable one, so we only see one layer at a time. So now we're just looking at the Gruan sites. You can see there's a small glitch in the software in that these little bubbles are not exactly over the sites where they ought to be. This, for example, is Lauder, New Zealand, and believe me, Lauder is on the mainland, not 100k off to the ocean. Okay, so we can click on any of these sites to get a little bit more information. If we click on the More button, so in here you get details about the station, what coordinate system they're working in. This is the original site where you find the original data. It's an NDAC FTP server here. It tells you what is being reported, so it's a temperature profile from Gruan in this case. It talks a little bit more about other things. Just see, there should also be in here the principal scientists should be in here. The name of the station, in this case Potenza in Italy. The data format in which the metadata was originally reported, which is the ISO 191115 standard. Contact person of the data originator, which is Fabio in this case. The PI, the name of the PI, you can find in here as well. So if you need to contact this person, creation date also you will find in here as a start of operation. So since 2011 there's observations available at this Gruan site in Potenza. It's up to present date, and this data was ingested into the database in March 2016. And the altitude above main sea level 720 meters. So that's the kind of information you can get from this metadata. On the different sites belonging to respective networks. Under the metadata menu, there's a couple of other entries in there. Most of them are not active yet. The cesium tool is already operational. It is not integrated yet. It will show you, or it does already show you, the overpaths of satellites and where and when they coincide with reference measurements. It's quite a nice tool, and it will be shortly integrated with the existing VO. So far it's still standalone. And then the maturity matrix, the data is also in the database. And we used to be able to plot this also, but currently this feature has a problem and we're not able to show it. But it would show you the maturity of the network, of this reference network. For example, if the level of documentation is there, full description of all the errors, continuity with measurements, and a number of other things. For details, please refer to Working Package 1, but have a full description of these things. Okay, and this is the end of this third tutorial, and I hope to see you shortly back at the fourth and last tutorial on observational data. Thank you.